Hello, Professor. My name is Huynh-Pham, and my co-worker in this project is Thanh-Pham. Today, we share our project on predicting PM 2.5 levels using a long short-term memory. In this project, we use historical PM 2.5 and weather data and treated it as a time series problem. We process and normalize the data and then divided the data into training and testing sets. We had some problems collecting the data, so two websites providing data for this project are OpenAQ and OpenMatel. They provide data through APIs, and it took us a lot of time to get the data, choose the location to get the data, choose the right sensor, and choose the time that the PM 2.5 and the weather data are on the same day and even the same hour. So another problem is that these sites do not let us get the data for a long period of time. We have to get the data on the weekly basis and compile them into a complete dataset. So that is why we have some Python files to process the data. So we have the collect data file to collect the data from these two websites, and then the validate and merge data to validate and merge just merge the data. And after run these Python 5, we have the data here. So we have the raw data. After run these Python 5, we have the data set for the 2.5 PM 2.5 data set, data for a week, and then the weather hours, the weather for to combine them together to have the complete data set. And after we have these file, we just merge the data into the pollution weather merge. This is our complete data set for this project. Back to the training process. So we build a long short-term memory model. This type of neural network is good at learning patterns over time because it can remember both recent information and long-term trends. And then after feeding in the data, we have we have 5 pollution features, 14 weather features, and 5 time features, such as PM 2.5, PM 1.0, NO2, temperature, relative humidity. So, and then we proceed to build and train the model and build the model. Yes, we build the long short-term memory model. After that, we have the result. After the model has been trained for many epochs, the training loss and validation loss gradually decrease. So this shows that the model has learned meaningful patterns from the dataset, and overall, the training process is stable and shows good learning behavior. So let's take a look at the test result. Okay, here, these graphs show that when comparing the predicted PM 2.5 values with the actual values, we can clearly see that the prediction that follow the actual trend. So the model can capture an increase and decrease of PM 2.5 quite well. But of course, there are times when like this or like this. So there are times when the predictions are off. So especially during spikes. So but overall, long short-term memories do a good job of understanding the general behavior of air quality data. And as a result, we get a model PM 2.5 prediction for the next day. So we took data from June until December 1st. So we made a prediction for December 2nd, and this is the result we got. So according to the model, the air quality dropped significantly in LA. But according to what I found on the internet, so the air quality in LA on December 2nd was not really good as the model predicted. So I think this is completely unavoidable. So the model predicts future events only gives a certain accuracy prediction because it is affected by many factors, but humans cannot control. So I think it is similar to stocks. So overall, we found that we learned a lot in this project, especially the ability to handle the raw data. So I think that is the main purpose of this project. So we also learn more about low short-term memory. So we will try some more models to compare reliability in the future. So thanks, Professor.